So we will have Vila, we will be delighted to have you and welcome you in Puerto Rico. So then, now to conclude this academic experience, we will finally will be able to meet the robot that will have been with us the whole week, the whole 2 days, because we have been carrying with the robot in the subway, so funny. We have Jairon, Jafet, Carrasco, Cortés, and Manuel Hernández Torres from Inter-American University of Puerto Rico. Come on, guys.
So there's some components that he's gonna give you guys so you can pass them on and you can see it yourself. Okay, good afternoon everyone. My name is Manuel Hernández. I'm a team mechanic.
My name is Jairon Carrasco. I'm part of the Programming, Communications, and Logistics team.
And this little guy right here is named Neptune. And well, together we are
Interrobotics.
Okay, so today we're bringing you guys our passion project, the innovation in Puerto Rican robotics. Let's start by defining the word innovation. Innovation can be defined as the presentation of new ideas, products, or pretty much anything new. Now, let me resume to you guys what we're going to be talking about today. We're going to be first talking about robotics. Who are we? What makes us? What do we do? Then we're going to talk a little bit about the robots, especially the mechanical components. There's many subsystems, so we don't have time for all of them. So we're going to focus on just two of them. In this case, the drivetrain system and the conveyor belt system. Then my teammate here, Jairon, is going to talk about the C++ programming, sensors, PAD, everything that makes this robot come to life. Then we're going to do a demonstration for you guys where we will show you how a robot works and what is he supposed to do for our competition. And finally, we're going to do a conclusion and answer all of you guys' questions. So, in order to start, let me leave you guys with Jairon, and he's going to talk about who we are.
Thank you. So, Interrobotics. Who are we? Interrobotics is a team composed of 14 Inter-American University of Puerto Rico bio-on-campus based passionate students in various branches of engineering. These include mechanical, computer, architectural, and also computer science. We are inspired by the different branches and the umbrella itself of STEM to continue contributing to our island's technological advancements. Interrobotics was born as a fun and passionate project to participate in the VEX Robotics Championships. Our first time competing was actually in the season 2023-2024 over-under season, where we got the privilege and honor to be crowned as the national champions and later represented Puerto Rico in the international competition where we ranked 12 overall out of 90 teams. Thank you. Thank you. As a fun little tradition, as we have in a team, we like to name our robots something that personifies our motives and yearly goals. The first time that we competed, we created 2 robots, and since it was our very first time competing, we decided to go with the names Neo Genesis, New Beginning. This time, in this season called High Stakes, we were focused, our mindset was placed on ascending as a team in experience and in knowledge. Therefore, what we decided is to explore, and we landed on the word ascendentium. It's a Latin word that means the ones who are ascending. We played around with the syllables a little bit and ended up with azen and dentium, who we also already presented to you guys. Azen couldn't be with us today, but we have dentium over here. That they have a similar design, but we will later on explain a little bit about it. So without further ado, let's talk a little bit about the mechanical components. So Manuel.
Okay, so as I stated in the beginning, we're just going to focus on two of these subsystems. And we're starting with our drivetrain. Our drivetrain was entirely made up from scratch. Why? So we wanted to install a motors. In order to install a motors, we needed a custom base. This custom base needed a custom transmission. This custom transmission needed custom gear ratio. So you can see where I'm going. Everything had to be custom. So let's start talking about the gears. Okay, so here I have a larger version of the gears. We had to design them ourselves because since it's a custom transmission or a custom gear ratio, VEX, which is the company that provides the competitions and the components for the robots, do not provide gears with the necessary teeth. I believe we have 52 on the smaller gears and 72 on this larger gear. So we had to go into CAD softwares, especially SolidWorks, in order to design our gears. And this gave us the opportunity, as you may see right here, of including our school's logo in the gear itself. Another thing, as I said, we needed a custom base to install these transmission and motors. So we ended up doing this design I have right here. It will go like this together, and you can see them in the robot sides. This is the outside. The inside obviously cannot be hollowed out, but in order to keep weight as light as possible, we decided to use this hollowed out honeycomb pattern that, well, works not only for the purpose we intended. Later on, we mechanics noticed that this helps us because these gears that we made ourselves tend to have wear and tear, in difference of the original ones that work perfectly and don't have tear and wear. Our gears tend to break. So with this hollowed out pattern, we can see into our transmission and see if we need to make a repair in that moment or in the future. As of now, the robot is not working perfectly, but for aesthetics, we decided to keep these gears because it works. But we know because we can see into that the system works.
It has some minor difficulties, but it's working.
It's working. Okay, and finally, in this presentation, as you may see, we have two simulations right here. The one on top was made using ANSYS software. The one on the bottom is SolidWorks. These pretty much are simulations on how would the forces applied would work. On the top will be the torque and the speed that the motors would provide to see if the teeth would share off. The one at the bottom is von Mises stress, which is technical, and we won't talk about that. If you have a question, we will answer it. But pretty much, it talks about the vertical force that these structures could hold, and we ended up with a number. So pretty much, this robot weighs 19 pounds, and obviously, not all of the 19 pounds are held by these structures, but this part I have right here, this is 1/3 of the size, 2/3 of the size. So this could hold, the real version, could hold up to 60 pounds in every square inch of the part. So 60 pounds right here. Now let's go to the conveyor belt. Our conveyor belt is pretty much the same system that every team used out there with two major differences. As you can see here, I have another two 3D printed components. These are hooks that we made gantry. Pretty much every every single team in VEX Nationals. We saw also the competition in Colombia and the World Championship. We never saw nobody using something like this. They all use metal, which we also used in the beginning, but decided to scratch because the metal tends to bind too hard onto the rings, which we will show you later, and goes right there in the post, which is called a stake. So we decided to build 6 versions in cats of these ganchos, as we call them. We renamed them ganchos. And here we have gancho 3.0 and gancho 6.0. These ganchos, each is more complex than the last, and all of them work. But we decided to go back to gancho 3.0, which was a simpler geometry, but turns out it worked better than the more complex geometry. And finally, the conveyor belt has a problem right here. This is provided by VEX. These tend to tear apart, so it will render pretty much the whole scoring system of the robot inoperable. And we decided to use 3D printing once again, using a rubber-like plastic material called TPU to build and print this chain you can see right here that will link everything together. So even if we have a failure to the stock linkage, our system will not come apart and will never be rendered useless. At least with failure in this part of the robot. So now I'm going to leave you guys with Jairon, and he's going to talk about everything that has to do with programming.
Thank you. So, as we know, robots cannot move on their own without the use of programming. So we could consider programming as maybe the neural links between each and every subsystem, because it tells the subsystems how they need to work, how they need to move. For this specific project, we developed 2 fully working C++ programs. One, and a little bit of context in this, for this specific competition, we had, for each round, 2 sections. You had an autonomous 30-second section where the robot would just move on their own, and a 1 minute and 30-second driven control round where the driver took full control over the robot. So we needed to develop these 2 working programs, one for each period of the round. And actually this part was a section that was really important for us and was really meaningful for us. The first time that we competed in the 2023-2024 over-under season, we developed every single programming section with programming by blocks. This specific year, we tried something new for our team, and we were mostly new to the team. The programmers that we had were mostly new to this whole programming world, but we decided to take on the challenge and learn and implement C++ programming for our robots. Now, why is this important? C++ programming in this specific part helps us to be more accurate in the commands that we set, be more precise and exact through the motion of the robot and how the subsystems work, and ensuring us a better advantage over the teams that we were competing with. To give a sense of direction to our programming section, we decided to implement sensors. Here you can see a few of the sensors that we implemented. The one that I have over here is called a potentiometer. This potentiometer was used specifically for the ARM subsystem that you can see over here. Why it was used in this ARM subsystem? This potentiometer has a 265 degree of motion, and it was perfect for what we wanted for the subsystem, the ARM subsystem. We also use inertial vision, we used the potentiometer, we used inertial, I already repeated that, and vision, and yes, perfect, those are the ones, I'm sorry, I keep getting those confused. And we also implemented PID controllers. What are PID controllers have a very wide set of uses in the robotics industry. PID controllers, or proportional, integral, and derivative controllers, are used to help the robot have a precise and exact move throughout the field. So it helps on the autonomous section. It was really important for us to implement a section and a program that was able to work with some limitations. So to have a bit of more context, in the autonomous section we have a field of 12 by 12 where we had a central line that these robots could not pass, or if they passed that central line, we would get disqualified. So we needed a tool that would help us to not exceed that central line and have a set of commands that would be more exact and more precise. Therefore, we utilized specifically the proportional controller, and that turned out to be the base of our autonomous. So, without further ado, I'm gonna stop talking a little bit, and let's get into the demonstration. Let's see how these components work in action.
Okay, so Jairon is going to set up the demonstration, and I'm going to talk a little bit about the components of the robot, as I said before. Here are in the line, and the purpose of this competition was to pick up the rings that he's putting down. Okay, so these rings are scattered around 12 by 12 arena, where both are robots, because both of them are the same. You can say that before. They're pretty much the same, with some key differences, but they essentially work pretty much the same. The differences in programming are that this one is a little bit slower than the other one. So now, if you guys could get closer so everybody can see. Now, I'm going to stop talking and we're going to just go straight back to the action. This one is Dentium. To discard the blue, and if we're playing for the blue team, to discard the red. So now we're going to leave you guys with Jairon. He's going to do a brief conclusion, and then we could answer some questions
such as this one, we are bound to be challenged in every way, shape, or form. We are bound to receive obstacles in our way. But when we work as a team, we are said to pass and overcome all these obstacles in our way. The mechanical pieces that we design, everything that we place in this robot, it just becomes easy when we work as a team. It's a more difficult job when just one person is working on it. But we're not just Manuel and Jairon working in this beautiful robot. No, we are Interrobotics. Interrobotics is filled with all of these people that we appreciate and love and couldn't be here, but these were the teammates, our teammates that worked day and night to prepare these robots and escalate us into the competition. Interrobotics is a team. We like to think of dreamers. We love to dream. We love to plan ideas. We love to set and just place our mindset high. And we believe that Interrobotics is a team with dream to reach galaxies. It represents the passions and aspirations of Puerto Rican students and the aspirations of the new generation that is arising. Therefore, Puerto Rico is not just a land of beautiful landscapes. It is the home of a generation longing to leave their mark on such a growing career field, robotics. This project materializes the passion and talent of Puerto Rican students, and the greatest goal and desire is to inspire future engineers and scientists to fall in love with STEM and continue contributing to our island's technological advancements. Thank you so much for your attention.
Thank you so much. But first, before we answer your questions, we would like to, thank you so much, I was going to show you guys. We would like to share, to give thanks to our sponsors, the one who made it possible that we're here. Let's start with Hex and Rosarado Torres for the invitation. Then Inter Bayamon, our alma mater, where all of our dreams, all the dreams and the passions for robotics comes to life. Then we would like to give a special shout out to Ciudad de Bayamon. That's the municipality we're based on, the city. Also, InstaJam for the beautiful uniform. And last but not least, Pratan Wheaton, one of our biggest sponsors from the beginning, and they're advocate for education in STEM. Okay, and last but not least, here you will find on my right, your left, you will find a QR code for a longer version of this presentation that goes a little bit deeper into more subsystems and the programming itself. Also, in there you will find our 8 engineering notebooks. If you're a gearhead like us, you will love these engineering notebooks because it explains everything to the last detail. Finally, I would like to talk about this other QR code, my left, your right. That's our team's Instagram. If today you have a question that we cannot answer for time or because we don't know, you can follow us on Instagram, shoot that question in DM. One of the other guys that have access to our account could answer it, or I'm planning making a live stream / YouTube video answering those questions in the future. So now, any questions? Okay, back there.
Okay, that is a wonderful question. Thank you. So our first inspiration to participate in the Vex Robotics, it all just started with a dream, really. The dream first sparked in our team's captain, Daniel Torres, that we saw in the picture in the beginning. He wanted to create this fun project because he loved robotics and he loved and participated in robotics in Vex championships before, and he wanted to share that space with new engineers and with his team. So when he decided to create it, he was just with this dream of just participating and giving a chance for others to fall in love with the Vex Robotics Championship as he did. So it all started with that, and time flew, and we also fell in love with this project. For this specific robot, we were inspired to continue the legacy of what we already started in the 2023 season. We saw so much, and we felt that that season was just the beginning of something new. We wanted to keep innovating, keep working, and it also helped us to apply the things that we learned in our classes and use them in a really fun and really beautiful project. We believe that university and the projects that we do, these all are connected. And we would love to show people that engineering is so fun. And we would love to inspire and continue contributing to that. Thank you.
Any other questions? Yes.
Yes, I am definitely not an expert on robotics, but this was amazing. I love to see such great integration of engineering in Latino communities. And why not dream about a Latino Tesla? What do you plan to ever do with this robotics program? Like, what type of robots do you dream to build? Because that would be great to see a Latino version of this, like this robotic.
Okay, so that question could have two answers. As a team, we plan on keep working for the Vex Championship. Next season, pretty much, is entirely a different game. The robot would definitely not work like this. Even the scoring object changed. So we're gonna keep working for Vex. As a personal level, myself, I really do like everything that has to do with robotics. And also today we talked a little bit in the other presentations of the other students. They talked about AI. So I really like the implementation and of all of these. I'm kind of a nerd, so pretty much when I see robotics and AI, I've seen them work together with ChatGPT when you could do custom GPT that he could talk. So pretty much I personally would like to build a small C3PO for my desk, and that's something we can do right now. Not something for the future, that's something we can build as a personal project right now. So if somebody is inspired by robotics, you don't have to be an engineer. You just have to look up information and you can build something like that. If that moves your boat, as we say in Spanish, I think it gets lost in translation, then you should go ahead for it.
If I could add to that wonderful explanation, we would also love to venture outside of the Vex world. Vex offers a range of amazing opportunities, but we know that this robotics field is growing constantly. So with our team, one of our team goals is to venture outside of this Vex world and continue expanding our horizons to different competitions or projects that could help us learn more of this and the implementations that it has with AI and the different technologies that are arising. Thank you.
Any other questions?
Yes.
First
Thank
of all,
you.
before Manuel answers
Yes.
that question. Oh, okay, so she asked about the C++ process and programming and everything that's related with that. First of all, as I mentioned before, if you scan the QR code, there's an engineering notebook for each subsystem that is divided by each subsystem and talks about the process of C++. And he's a programmer, so he can talk to you about this.
Yes. By the way, thank you for the question. Yes, the engineering notebooks include a very detailed process of the code itself, including the code itself that is working on these two robots. It's even divided by all the different CPPs that we did for the program. But yes, it was pretty difficult especially since we were newcomers into this world. But we love that in our in our programming team, we had experienced programmers before. We had that computer science student helped us a ton, and our team leader. We basically took these all backgrounds, the backgrounds and the knowledge that they had, and we merged them together. We worked as a team, and even though it was a bumpy road to get to where Dentium and Exen are working right now, it was a very beautiful and very inspiring trail to walk on, because it challenged us to never put a limit on our knowledge. If we actually want this to work, and we put in the work, we put in the hours, we can make this, and we can make other upcoming projects and upcoming new things that this project only is the start, and we would love to think that the things that we learned, even though that they were difficult to acquire that knowledge, we know that when working as a team, it just becomes easier, and we are going to continue implementing that type of dynamic going on forward. Thank you.
Okay, so we don't have time for more. So if you would like more information, we're happy to talk to you guys after this ends. And for now, my name is Manuel.
My name is Jairon.
And this little guy here is Dentium, and we are
Interrogues. Thank you.
Okay, so now thank you for this amazing presentation. I'm so proud because I'm Puerto Rican and those are Puerto Rican students. So I'm happy to close this academic presentation with this presentation, and also thank you Lehman College for hosting us, and also Bronx Community College for coming and very excellent presentations. We're gonna finish the official part, the academic experience now, but don't leave because we have a closing reception behind us, and also we're gonna select some students to do some interviews, one per each institution, to record your feedback and your what do you take and what do you like the most about this student passport, so we can continue improving this experience for you. Thank you again, and remember tomorrow we have the workshop with Albert Roche, and also the lunch and the burgerology. Tomorrow we're gonna meet at 8:30, so you have more time to rest. Breakfast is on your own, so because in the place they only gonna serve lunch, so be sure to